Okay, in this video we're going to do another test of a proportion of a binomial distribution, but this time we're going to actually calculate the test statistic using a calculator. So it says, in the main branch of a supermarket, customers bought Thai to non-Thai ready meals in the ratio of 2 to 3. The management wants to test to see if it's true in another express branch, and found that in a random sample 12 that two customers bought Thai ready meals. Test at the 5% level of significance whether or not the proportion of customers buying Thai ready meals in the express branch is different to the main branch. This word different is quite important in this question. So the proportion of customers buying a Thai ready meal from the main branch is 2/5. And you get 2/5 because we've got a ratio of 2 to 3. A ratio of 2 to 3 is one part of it is 2/5, and the other part of it is 3/5. Let P be the proportion who buy a Thai ready meal from the express branch. Let X be the random variable, the number of people who buy a ready meal at the express branch. Then H0, P is equal to 2/5, because 2 out of 5 people buy a Thai ready meal at the express branch. And the alternative hypothesis, because we want it different, then P is not equal to 2/5. The proportion is not 2 out of 5 who buy a Thai ready meal from the express branch. And because it's not equal to different, then this is a two-tailed test, as opposed to looking for definite improvement or not improving. That would be a one-tailed test. So calculating the test statistic, we've got the probability that X is less than 2. This is sometimes you have to do this with a calculator because maybe the value of P is not available in the tables, or the value of N is not available in the table. So we've got Px is equal to 0, Px is equal to 1, Px is equal to 2 is the probability of being less than or equal to 2. So X will be binomially distributed, N is 12, and the probability of success is 2/5. Calculating that, it's 3/5. 1 minus 2/5 to the power of 12, i.e. nobody buys one. One person buying them is 12 times 2, 2/5 to the 1 times 3/5 to the 11. And then the last one will be 12C2, 2/5 to the squared, 3/5 to the 12. This is 12C1, which is 12. Working that out on my calculator, I get 0.08344 using a calculator. And now I must make a conclusion. Well, as 0.0834 is greater than 0.025. Why did I use 0.025? Because it was a 5% test. Okay, so because it's two-tailed, you're considering both extremes, and therefore one extreme will just be half of 5%, which is 2.5%, which as a decimal is 0.025. Now this value is bigger than this, therefore we do not reject H0, and there is no evidence that the proportion of customers who buy a Thai ready meal at the express branch is not different to the main branch. Okay, what does that look like on a diagram? Well, if we go to GeoGebra, okay, you can go get to the probability calculator, ask for binomial, set it for 12, and 2/5 is 0.4. Okay, we want probability less than 2. We can see that we got the same value as GeoGebra at 0.0384. And what we are looking is the two extremes, because it's a two-tailed test. So using a diagram, H0 is 2/5 and H1 is not 2/5, a two-tailed test. So if we use a diagram that I just shown you, which you can get on GeoGebra, right, using these probabilities here, we can sum up to see where 5 percent is, and we can see that 5%, sorry, we want 0.025%. 0.025 as a probability, 2.5%. If we add these up, we will see that that value of 2.5% will be somewhere here, and here we will reject H0 where it's 2.5 or 0.25, but because it's two-tailed we have an upper tail. This is where we split up the 5%. We reject H0 if this is 2.5 or 0.025. My value is all these probabilities, which is 8.34% or 0.834, and we know that 8.34% is definitely more than 2.5%, and therefore, as that is true, we do not reject H0, and that's why we, using a diagram, that's how we would arrive at the conclusion. Okay. However, you don't need to know the diagram, but the diagram will help you understand what we're doing here. Okay, this has been a video to show you how to do test a proportion, an observed proportion from a binomial distribution, and calculating the test statistic using a calculator rather than commutative distribution tables. I hope you've understood, and I thank you very much for watching.